So, hi, today I'm going to discuss the next question in Lead Code Top Interview 150 Study Plan. That is the 10th question in the series, Jump Game 2. So, this is going to be a follow-up question to the previous question, Jump Game. If you haven't watched that video, please go ahead and watch that first. So, uh, like the previous question, we need to calculate how we can reach the end. In this question, the test cases are generated so that we are bound to reach the end. But the condition here is the follow-up question basically is we need to calculate the minimum jumps to reach the end. In the previous question, we only needed to calculate whether we can reach the end or not. So that is given, we can reach the end, but we need to minimize the jumps. So similarly, like the previous question, the brute force here also can be used, like trying out all the possible paths, but that would give us a explanation time complexity, and we don't want that. Greedy solution is possible in this question also, so let's try and see that. So let's define an initial jumps, that is our answer, to be 0, considering we haven't done any jumps yet. Then we are going to basically use two pointer, basically not actually a two pointer approach, but we are just using two pointers. So let's name them left and right. So L for left and R for right. So beginning from the first element, that is I is equals to 0, I less than nums dot size I plus plus. So, like in the previous question, we defined the max and we tried to maximize it. That is the maximum index we can reach from a current index. So, in this question, we are going to keep buckets. Buckets in the sense, like from the first index, we know we can reach two more indexes. So, we are going to calculate for all of these two possible indexes and calculate max from them, and then we are going to iteratively make new buckets that are possible after iteration from the previous bucket, so that we can know from this bucket we could jump maximum till that bucket, then that, and that's how we are going to increment jumps and get to our final answer. So let int farthest be initially equal to 0. Then what I'm going to do is start from the let int j is equals to L. J is lesser than equal to R, J plus plus. So throughout the iteration, I'm going to make and find out the maximum farthest I can achieve. That is max between the farthest and to the previous question, that is the current index I plus the maximum jumps we could possibly do from that index. So that is nums plus I. Once we are done with this, we need to do is update the left and the right. So to do that, what we can do is make the current L is equals to R plus 1. That is the current rightmost possible index that we can go till is now the starting point of our next bucket. And similarly, the new ending point will be the farthest. That is the farthest we can go that we calculated above in the loop. To end this, we need to do jumps plus plus. So why we need to do jumps plus plus? Basically to count the number of buckets we have gone through to finally reach it. So once all our we know ki we are bound to reach the end. Once we are done iterating, we know key finally we have reached the nums dot size and there are no possible more possible iteration. So we could simply go ahead and return jumps. So let's see if it is working fine. So there's a compilation error. Okay. Undeclared. Okay, I didn't do int j. Int j. Okay. So let's see if it is working fine now. So there it is giving us a wrong answer. Okay. There might be some error. So basically, I did an error. We don't need to actually go through all the possible indexes. We just need to use a while loop here until r is actually lesser than nums dot size. So nums dot size, and we are going to use a while loop here. So let's see if it is working fine now. So there's an error again, I plus 1. Okay, it is, we're using j here. Okay, so let's see if it is working fine now. So it is working for the preliminary test cases. Let's test for all the test cases. So yeah, it is giving 100% time complexity. So basically, we are using a while loop. We are using a loop inside it, but we are going through each and every index only once because we are like uh, going through the from L to R in this loop, and overall number of buckets through above. So basically, we are going through the whole array only once, and other are like constant operation like incrementing jumps, changing left to r plus 1, r to farthest. So the time complexity can be said as o of 1, o of n, and the space complexity is constant because we are not using any extra space. We are just using some constant variables like jumps, L, R, and farthest. So yeah, that's it. Thank you for watching.